Okay, I would like to go ahead and finish the 3 examples I didn't have time in class to do yesterday. So this will help you with your homework assignment that you might hopefully be trying to complete this morning. Then I'm going to also post some notes about chapter 15 to get us started on that. So in your book, so you might want to turn to your book, although I do have the problems written down here. You roll a fair die 3 times. What is the probability that, and the first problem says you roll all 6s. Well, since each die is independent, actually it's the same die 3 times, but it can't remember what it rolled the first time. Remember that it's independent because the outcome of your second roll is not affected at all by the outcome of the first roll. So rolling all 6s, you have a 1 in 6 chance, or 1/6 is the probability, times 1/6 times 1/6. So we get, when we multiply those together, we get 1 out of 216. Okay, next one, you roll all odd numbers. Again, the dice are independent, so the probability of rolling an odd number the first time would be 3 out of 6, because there's 3 odd numbers, or that reduces to 1/2, times on the second roll, also 1/2, times on the third roll, also 1/2. So we multiply those together because they're independent events, and we get 1 out of 8. On part C, what's the probability none of your rolls gets a number divisible by 3? So first let's think about the numbers divisible by 3. Those would be 3 and 6. So we're saying none of our rolls get a 3 or a 6. So that means my first roll can get a 1, 2, 4, or 5. So there's a 4 out of 6, or 2/3 is the probability of not getting a 3 or a 6. The second roll would also be 2/3. The third roll, also 2/3. So I get 8, multiply across the numerators, over 27. Part D, what's the probability you roll at least 1 5? Okay, remember we talked about what to do there. The probability of at least 1, let me spell the word 1 so we don't, at least 1 5 equals 1 minus the probability of no 5s. You want to get in the habit when you see at least 1 to solve this problem instead. It's much, much easier. The probability of not getting any 5s, that means you don't get a 5 on the first roll, so there's a 5 out of 6 probability, times you don't get a 5 on the second roll, and you don't get a 5 on the third roll. So we have 1 minus 125 over 216. Okay, think of this as 216 over 216. So really all we need to do is subtract 216 minus 125, and if you do that, you get 91 over 216. So that's your probability that you would get at least 1 5. And then the last one, the numbers you roll are not all 5s. So let's think about what that means. They're not all 5s, so they can be anything except 3 5s. So that we can get anything, any other roll except that. So we want to do 1 minus the probability that we do get 3 5s. So we're going to have the probability of getting 3 5s is 1 out of 6 times 1 out of 6 times 1 out of 6. So that was 1 out of 216. So then 1 minus that probability, we have 215 out of 216. Okay, so hopefully that will help you with some of your homework problems. Got a couple more to show you. Okay, this is problem 30. To get to work, a commuter must cross train tracks. The time the train arrives varies slightly from day to day, but the commuter estimates he'll get stopped on about 15% of workdays. So some of you may have experienced that, getting stopped at the railroad tracks and having to wait for a train. So that's what he's talking about here. During a certain 5-day work week, what's the probability that he gets stopped on Monday and again on Tuesday? Now, in this problem, we're assuming, it says we're assuming that it's, somewhat from day to day is somewhat independent when we go through here. So the probability of getting stopped on Monday and again on Tuesday, notice we're not saying anything about Wednesday, Thursday, or Friday, so we're just looking at the first 2 days. So if his probability of getting stopped on any day is 0.15, and we're saying they're independent, then the probability that he gets stopped on Monday and on Tuesday would be the probability is stopped on Monday, 0.15, times the probability he stopped on Tuesday, 0.15, and we get 0.0225. So that would be the probability that he would be getting stopped on Monday and then again on Tuesday. The next question says, what's the probability he gets stopped for the first time on Thursday? Okay, think about that, what that means. That means he didn't get stopped on Monday, he didn't get stopped on Tuesday, he didn't get stopped on Wednesday, and he got stopped on Thursday. So the probability first stop on Thursday, he didn't get stopped on Monday, that would be 0.85 because it's 1 minus 0.15. He didn't get stopped on Tuesday. He didn't get stopped on Wednesday. Oops. But he did get stopped on Thursday. So we're going to multiply this out. And if you do that, you should get 0.0921. And you might want to verify these. I got my calculator handy. I'm not showing you that part. But that's what you would get there. Okay, next, the probability he gets stopped every day. So that means he gets stopped on Monday, on Tuesday, on Wednesday, on Thursday, and on Friday. So we're going to take 0.15, and I'm just going to write it this way to the 5th power, because he gets stopped every day. So if you evaluate that, you should get, now your calculator, if you do this on your calculator, you need to make sure you are aware of what your answer shows. Actually, let me go ahead and get this one out. That was going to be for something next here. So if we have 0.15 raised to the 5th power, make sure you know what that means, this e minus 5. So this is scientific notation, 7.59 times 10 to the negative 5th power. So we're going to move the decimal point 5 places to the left. So we end up with 0.0000, and I'm going to round. This is a 5. This goes to an 8. Okay? So very slim chance that that he would get stopped every day. The next one, what's the probability he gets stopped at least once during a week? Okay, again, at least once is going to be the probability at least once equals 1 minus the probability not at all. That he gets stopped, not at all. So we have the probability that he doesn't get stopped at all. That would mean he doesn't get stopped the first day, or the second day, third day, fourth day, and the 5th day. Okay, so he doesn't get stopped at all. So we're having, okay, so that probability would be 0.85, that he doesn't get stopped on any of the days. So we're going to take that, and we're going to subtract from 1. So we have 1 minus 0.85 raised to the 5th power. So we get 0.5563. And you'll find that I usually round to 4 decimal places when I'm dealing with probabilities. Okay, here's problem 33, but I've changed it up just a little bit. You bought a new set of 4 tires from a manufacturer who just announced a recall because 2% of those tires are defective. Conduct a simulation to estimate the probability that at least one of yours is defective. So if we were, I just want to go through the process. We might not do this whole thing, but this is a simulation problem, and this is similar to what we did in Chapter 11. So you might do something like let 0, 0, and 0, 1 represent defective. And 0, 2, whoops, we got some problems here with this. Hold on just a second. Sometimes I have a problem with if I'm not using a block pen, I don't really know why. Okay, so 0, 2 to 9, 9 is not defective. Okay, then we could go through and randomly generate. So maybe you want to do math, probability, random integer. I guess I could have chose 5. Oops. Yeah, I should have done it that way. All right, so let's do, and I'm going to go 0 to 99 because my calculator won't do the 2 digits on those. And I'm doing 4 tires. So I could go through this, and here I'm looking for a 0 or 1. So here none are defective. So I could make, a little mark, at least 1 defective. So at least 1 defective versus none. So here I'd mark a little tally mark for none. And I do this again, none. Do it again. Okay, and I could go through this process. Now I'm probably going to have to do a lot of trials because my probability of having defective is so small. We don't have to do it with a simulation because now we know another way to go about this. So if the probability, we want at least 1 is defective. So the probability at least 1 is defective equals 1 minus the probability none are defective. So we get the probability none are defective means the first one's not, well that's 0.98, the second one's not, the third one's not, and the fourth one's not. So this is the probability none are defective. So for our at least 1, we're going to do 1 minus 0.98 to the 4th power. So we take 1 minus 0.98 raised to the 4th power, and we get 0.0776. This is the probability that that at least 1 is defective. Okay, so that should help you out. You should be able to do all the Chapter 14 problems I assigned. So get those done, check back here, and see so we can get started on Chapter 15.